So we're looking at sound waves, but just a bit of revision for now. So sound waves are longitudinal waves, and if you're looking at the slinky spring, the place where the springs are close together is known as compression, and the distance between the compressions is known as rarefaction. So sound waves, the objectives are how do sound waves vary with frequency, what is ultrasound, what can ultrasound be used for? So in space, no one can hear you if you make a sound. That's because sound needs a medium or a substance to travel through. And sound is a series of vibrations in the medium, one set of particles bumping into the next, carrying the vibrations through. And the denser the material, the quicker the sound travels. And that is because, for instance, in solids, the particles are very close together, so therefore the sound can travel faster. So high notes. So sounds are vibrations, therefore we can measure the rate of vibrations, so the number of vibrations per second. The more vibrations per second, the higher the frequency. So if we looked at a piano, the lowest note on a piano has a frequency of 32 vibrations per second. And if you could see the string vibrating, it would go to and fro 32 times per second. And we call this 32 Hertz or Hz. The top note on the piano is over 4,000 Hertz, which is 400 vibrations per second. So now if we look at human hearing, so it's actually the frequency that determines how high or low a note sounds. So humans can hear notes of up to 20,000 Hertz, although hearing deteriorates with age, which is why children and teenagers probably hear a lot higher pitched noises than older adults. So if we now look at echolocation, so although humans can't hear anything higher than 20,000 Hertz, other animals can. So bats use frequencies of 40,000 Hertz to navigate. Cats can hear some of these notes and try to catch the bats. Other things that use echolocation, things like dolphins. But the definition of echolocation is frequencies that humans can't. The definition of an ultrasound is frequencies that humans can't hear. So ultrasound uses. So one of the uses is cleaning jewellery, the dirt particles off jewellery. Another use is muscle massages. Just a quick look at hearing ranges. So here is human hearing range. So up to 20,000 Hertz. Pigeons can actually hear a bit lower than us. Mice can hear higher pitched noises than us. You can actually get devices in your home that do a high pitched sound so that you don't get mice if you lived in like a farmhouse or something. Elephants can hear lower noises than us. Moths can hear higher noises than us. Other uses of ultrasound, which is more than 20,000 Hertz, that should say kilohertz, are scanning fetuses, dog whistles and scaring devices to scare rodents away. Bats and dolphins use echolocation, so they send the ultrasound out, and then it echoes back off the wall so they can find distances between things. Hoodies, shopping centres. So what they used to do, I don't know whether they still do it, is they had these really high-pitched devices that teenagers and young people could hear, but older adults couldn't, to prevent lots of teenagers hanging around certain shops. I'm not sure how lawful that is, so I expect that it wouldn't really, that they don't do that anymore. Okay, now if we look at loudness of sounds, that is decibels. So if we look at the range of hearing ranges, some really loud noises can actually deafen you. So working above 80 decibels can damage hearing. So people that work in loud environments have got to wear like earmuffs. So we all have slightly different hearing ranges, but about 1 in 5 people suffer some sort of hearing loss, and this changes with age. So a baby has a wider range than an older person. And temporary hearing loss can be caused by ear infections and colds, and your hearing recovers. but there could be permanent hearing loss and deafness, which can be present at birth or if the ear is damaged or diseased. Loud noises can also cause nerve damage or cochlear damage and can damage the cilia. That's why musicians, etc. use earmuffs and ear protection. We said before that people have different audible ranges. Hearing range of pitch varies. Some can't hear really high-pitched sounds because they might have wax which is blocking their ears. They might have nerve damage. They might have damage caused by infections. They might be older age. And things like dogs, bats, dolphins, etc. can hear higher frequencies than humans. And again, some people can't hear quieter sounds. So loudness is measured in decibels. Young people can hear quieter sounds better than older people. And if you've got good hearing, you tend to have a good audible range. And hearing can be damaged by loud noises from machinery, etc. So that is a bit more about sound.